Good afternoon. So today we came to our plumbing class day 10. So last day we were dealing with some, water management system and all those things, and hot water system, etc. etc. So today our topic is auto pneumatic system. Okay, auto pneumatic system. It is one type of indirect system of water pumping. Okay, normally we know that the water from the well or the underground tank or rainwater tank is being pumped from that place to the overhead tank. From the overhead tank, it will be supplied to the individual fixtures. Okay, so today we will be dealing with an auto pneumatic system in which we will be directly from our pump. We will be having a pump system, and that pump system will be or that water will be in a pressurized condition, and that water will be supplied to the individual fixtures directly without it is sent to the overhead tank. Because when we are trying to give the supply through the overhead tank, it is being flowing by the help of gravity, right? So we have to keep the overhead tank in an elevated positions to get the proper pressure at our different fixtures. Okay, we need to get correct pressures at our different fixtures so that we'll be adjusting the height in such a way that to get a proper pressure. But in this case, we are not directly pumping it to the overhead tank. Rather, we are directly pumping from the well or the underground tank or the source of water directly to the fixtures. Okay, directly to the fixtures. Okay, so actually there will be two or three pumps. Okay, there will be two or three pumps, and there will be a pressurized tank. Okay, in which there will be water as well as there will be air, so that when we are supplying the water to the different fixtures, we can give a pressurized water at a set pressure. Okay, without losing any without any fluctuations in the pressure. So we'll be having a cylindrical tank. Okay, which will be filled with water as well as compressed air, and by the help of that setup, we'll be directly giving pressurized water to the different fixtures. So we'll be studying about what is the working that is happening inside the auto pneumatic system. We'll be solving different questions related to that to find out the tank capacity. Okay, how much tank capacity that we need. Okay, so as it is as it is mentioned, auto pneumatic means it is depending upon or it relates to air. Okay, so it relates to air. So auto pneumatic system, where we are using compressed air, and that when the air gets mixed with this water, what happens? We'll be able to supply the pressurized water to the individual fittings or fixtures. Okay, so we'll be studying about auto pneumatic system, and we'll be studying about booster pumps, jockey pumps, etc. like that. Okay, so I will share my screen. So if you want to write a heading, you can write auto pneumatic system. Auto pneumatic system. So this is auto pneumatic system. So as the word implies, pneumatic, it will be dealing with air. It will be dealing with air. So yeah. So water supply system. Okay, water supply system. So you can see here, this is just a diagram here. Okay, there will be three pumps will be there. This is auto pneumatic pump from the well or from the underground tank. By the help of the pump, it will be directly giving to the fixtures. We are not directly giving to the overhead tank. From overhead tank, it is not coming to the individual fittings, but directly from the pump, we just pumping it. Okay. So in order to maintain a proper pressure, we can set it. We can set the pressure. Okay, we can set the pressure here, and without losing any pressure. That's why we will be using a cylindrical tank. Okay. so that we will be getting a proper regular flow as well as pressure. Okay, so let's see what is happening there. Okay, so this is the auto pneumatic system, and you can see here, you know, actually this is a typical commercial building with pneumatics tank system. Okay, and you can see here, this is the panel where you can see different parameters, and this pump system, and this can be the city water main, and that can be stored in a tank, and from there you can just pump, and there will be a pneumatic tank also. There will be a pneumatic tank. Okay, where we will be having where there will be filled with water, as well as it will be filled with air. Okay, both air as well as the water will be filled in this pneumatic tank, and there will be pump. Okay, it can be 2 or 3 pumps. Okay, according to our need, the pump will be working. Okay, sometimes it will be 1 pump, 2 pump, or 3 pump. It will be working depending upon the need, on the demand. Okay, so this is the building with a pneumatic tank system. Okay, so in a building you can give water to the overhead tank, and from the overhead tank, by the help of gravity, you can give. This is another system where you can supply the water to the individual fittings to the automatic system. So I got a project, and I have did a project with a pneumatic system. And why I have used that is that because it's a resort. Okay, it's a resort here. It's the resort name is Hyatt Resort. So it is almost in things of uh, 13 acre 13 acre plot only. Okay, 13 acre plot. So the buildings are in different areas. So the buildings are located in different locations. So we had a we had a big tank. Okay, underground tank. On the top of the tank only we'll be getting the auto pneumatic system. Then from the auto pneumatic system we'll be having filtration system. Okay, then by after filtration only it will be going to the different fittings at different locations in that building. And I will just show you the diagram and or a schematic where I have designed it. Okay, that also I will show you. And before that, let's see what is the working and all those things. Okay, and this system is being taken and shown here, enlarged. Okay, this system which is kept in the ground floor is being shown enlarged here. Okay, so this pump system is this one, this tank is this one. Okay, so let's see. So this is the incoming water. Okay, it can be from the well, or it can be from the underground storage tanks. Okay, so you can have pump set. You can have one or 2 or 3 pump set according to our demands. Okay, so this is the valve and pump. Okay, from there it is giving one connection to the cylinder. This is the this is the cylinder where there will be water as well as there will be compressed air. Okay, there will be water as well as compressed air. In this tank, there will be a drain valve, a pressure release valve is there because a compressed air has been stored inside this. There will be a float switch. There is a float switch for air. Okay, this float switch so that we can know the level. Okay, and this is another level gauge, water level gauge to know the water level. Okay, and there is a pressure gauge. We can know the temperature, so we can know the pressure inside this tank by the help of pressure gauge. And there is an air pipe is there which is attached to pressure switch for water. So it can actuate it if there is a less amount of pressure or a pressure drop is occurred by the help of pressure switch, it can activate. Okay, it can activate and we can give compressed air. So you can see here there is an air compressor. So when there is a deficiency of air, or when there is a deficiency of compressed air, automatically what happens? This air compressor will on. It will start and it will give a sufficient air, all right, sufficient compressed air to this tank. And when there is a water level decrease, what happens? There is a set pressure. Okay, so there is a set pressure as well as a set water level is there. According to that, this pressure switch will activate. Okay, and when you need to start the pump, it will start and it will give the water to this. And if there is a less pressure or air inside it, automatically the air compressor starts. Okay, so So this, the water will be passing, and it will be given to the different fixtures, and one connection will be attached to the storage tank. So what happens is that when this is being supplied to different fittings, right? So if you open one fitting or if you open one tap, what happens? The pressure reduces. So when pressure reduces, what happens? That has to be accompanied or that has to be compensated by this tank. So we'll be making sure that there will not be any pressure drop or there will not be any fluctuation in the pressure. So we can distribute the water at an equal pressure. Okay. So because for that setup only we have set this tank. Okay. So you know that when different fittings is been opened, instead of three taps, five taps are opened, automatically the pressure can drop, right? Pressure can drop. So that pressure drop can be compensated by using this tank system. So this water will be always will be stored with that pressure. Okay. So when there is a drop, that will be compensated by this. Okay. So let's see what are the different things that happens here. Okay. In auto pneumatic system is an indirect system of water supply or firefighting system to a building. So you can give water supply directly to to the different fittings, as well as it is we can use it for the firefighting system to the building also, because we know that in the firefighting system the pipelines will be always will be in a pressurized system only. Always it will be in a pressurized system only. So sometimes when a fire occurs, a high velocity, high pressure water will be will be spreaded or supplied to the particular building or particular space. So always in a firefighting system, the pipeline will be in a pressurized state only. So you can do auto pneumatic system. Okay. So auto pneumatic system is an indirect system of water supply or firefighting systems to a buildings. A steel cylinder, that's what we have seen here. So mainly we have a steel cylinder and we have a pump, we have a compressor, okay, and a pressure switch to detect whether the air is low or water is low, like that. According to that, it will start and stop. Okay. So auto pneumatic system is an indirect system of water supply or firefighting systems to a buildings. A steel cylinder under pressure is used to supply water at required pressure. So we have a steel cylinder under a pressure. Okay, this water will be under pressure. Okay, used to supply water at the required pressure to fittings instead of providing roof tanks. So this is an alteration method where we are not giving roof tanks. Okay, here we are directly giving pressurized water directly from the pump. Okay, so the steel cylinder contained by the water is pumped into the roof. Okay, pumped into the bottom. So this said that the steel cylinder contained by the water is pumped into the bottom. So you can see here, you know, uh, the water from the incoming water main by the help of the pump set is being directly pumped into the bottom of the tank. Okay, bottom of the tank. Okay, now compressed air forces allow water to reach high level points. So compressed air forces the water to reach the high level. Okay, so you can see here, in this side there is a compressor. There is a compressor here. By the help of compressor through the air filter, it goes through the this pipe, and compressed air is being supplied into the other end of the tank. So this area will be filled with compressed air. This will be filled with water, and this area will be mixed with the compressed air as well as water in this area. So high pressure is being pumped here, okay, and water is the high pressure air is being supplied here. Okay? It is been pushing down. It is been pushing down because of the compressed air. So this tank is highly pressurized tank. So the compressed air forces allow water to reach to high level points. Okay, so it will allow the water to reach to a high level points. So when water is drawn through fitting, so this will be in a high level, and not only that, it will be in a pressurized state, and the water inside this pipe will be in a pressurized state. Okay, so when you are trying to open one tap, you are trying to open one fitting. Okay, what happens when water is drawn through fittings? Water level in the cylinder goes down. So So always this water, there is a water level. Okay, the water will be filled here, pressurized water will be there in the pump. Okay, then if you are trying to open a tap or whatever it may be, what happens is that the water will be flowing, right? The water will be flowing, and what happens is that the tank will be from this tank only the water will be supplied. Okay, from this tank only water will be supplied, and what happens is that the according to the need or according to the demand, the water reduce. The water level will reduce because the water is taken from this water tank only. So it will reduce it. Okay, because one pipe is been opened. So that what happens when water is gone through fittings, water level in the cylinder goes down, and a pre-decided low level a pressure switch of water pump is on. Okay, so there is a pre-decided water level. So you can set the water pressure water level. You can set the water level. Okay, which means that uh, so water level not we can decide a pressure switch. So and we can set it that at this level we can cut off. In this level we can cut it. Okay. So if there is a high level, the pump will be automatically cut off. When it comes to the water will be coming down at a particular set point. What happens? Automatically, what happens? The pump will start working. Okay, so we can set the pressure here. We can set the pressure here. Okay, so when water is gone through the fittings, water level in the cylinder goes down, and a pre-decided we can set the level of a pressure. Okay, by the help of a pressure switch, we can set a pressure switch. Okay, and if it is going below that pressure, suddenly the pump will start. If it is going above that, or if it is reaching that level, it will stop the pump. Okay, or the compressor. Now, at the pre-decided lower level, a pressure switch of water pump is on. Okay, so when the water level decreases at that level, at the pre-decided set level, what happens is that the water pump is on and the tank is again refilled with water. Okay, because the water has been drawn, right? The water has been drawn by the fittings. So the water level decreases. At the set point, what happens? It will detect. Okay, the pressure switch will detect. Okay, it goes beyond that level. So what happens? It gives information to the pump to start the pump. Okay, so it will start the pump, and what happens? It will again increase the water level inside the cylinder. Okay, and the water is refilled with water, and the tank is refilled with water. When water level rises in the tank, a pre-decided high-level pressure switch cuts off the pump. So when it reaches the high level or a pre-decided high-level, pressure or a high level of water, what happens is that it will cut off the working of the pump. Okay, or it will stop the pump so that we can maintain this pressure between this 4 bar or 6 bar. Okay, you can set the pressure at 6 bar and you can set the low level pressure switch at 4 bar. So when the water level is coming and the pressure decreases, what happens? It will cut in. Or you can set to a different level. Okay, if the water level comes to this much height, okay, you have to stop. When the water level comes to this much height, you have to on the pump. Okay, you can do like that. So when water is drawn with the fittings, water level in the cylinder goes down, and a pre-decided low level, a pressure switch of the water pump is on, and the tank is refilled with water. When the water level rises in the tank, a pre-decided high level pressure switch cuts off the pump. Okay. So next point, air in the pressure cylinder gets absorbed into the water after some time. So you know that there will be a cylinder, and one portion, bottom portion will be covered with water, and the top portion will be covered with compressed air. And the top of the water will be already, because of the compression of the air, what happens is that this water will be in a pressurized state of it. Okay, the air in the pressure cylinder gets absorbed into the water after some time, and the quantity of air available in the tank become less. Okay, so what happens is that the air in the pressure cylinder gets absorbed into the water after some time, and the quantity of air, okay, there is a set quantity, okay, of the air available in the tank becomes less, which causes less pressure to water. So after some time, when the water gets absorbed by this air, what happens is that it loses its pressure, okay, and the tank becomes less which causes less pressure to water, and the frequency of start and stop of water pump is increased. Okay, so what happens? The frequency of start and stop water pump is increased. So it will be going below, that level. Again, it will be starting. Then it will be reaching to a level. Then again, it is going down. Then again, it is coming up. So the frequency of the start and stop water pump is increased. Okay, so then a float switch fitted in the tank starts air compressor. This time we were dealing about the water pump only. How it starts, how it cuts off, which level it cuts off, which level it starts. Okay. Now a float switch is fitted in the tank. So you can see a float switch for air. Okay, a float switch for air. You can see here a float switch. Okay, a float switch for air. Why we need the float switch? Air in the pressure cylinder gets absorbed into water. After some time, the quantity of air available in the tank becomes less, which causes less pressure to water and frequency of start and stop water pump increased. Okay. Now, what is the purpose of a float? A float switch fitted in the tank starts the air compressor at high water level. Okay, and operates until the required volume of water gets into the cylinder. So, a float switch is being fitted in the tank. Okay, a float switch is fitted in the tank. So when the water is being pumped, and it reaches to a high level, what happens is that when this float also will be coming up with this water level. So that is the use of this float. Okay, so when the water increases, the float also will increase, or float also will come up by the rise in the water. So what happens is that the float switch fitted in the tank starts the air compressor at high water level. So when the water level reaches to a high level, what happens? The air compressor gets starts. Okay, fitted in the tanks, the air starts air compressor at high water level and operates until the required volume of water gets into the cylinder. So the air compressor will be working, and it will work or operates until until the required volume. Okay, until the required volume of air or until the required volume of water gets into the cylinder. Okay, so the float switch is fitted in the tank to start the air compressor at the high water level and operates until the required volume of water gets into the cylinder. So it will be set up in such a way that the air compressor starts, okay, and at the high water level till the water till the required water volume. Okay, so the total air and water volume in meter cube. So inside that tube, inside that cylinder, the total volume will be the volume of air plus the volume of water. So there will be volume of water and there will be another layer of volume of air. So the total volume of that cylinder will be volume of air plus volume of water. Okay. So we will be doing some problems, okay, to find out the capacity, and the formulas that we will be using is this: volume of tank, okay, VT, volume of tank, or the total volume, equal to BW, water volume in tank in meter cube. This is the volume of the total tank. Okay, so you know that inside that tank you will be having water as well as you will be having air. That is the total volume of the tank. So the formula is VW, water volume in tank in meter cube, divided by 1 minus sigma B. Sigma B means ratio of minimum and maximum working pressure. Okay, so this is the ratio of minimum and maximum working pressure, which varies from 0.65 to 0.85. It's a constant. It will be varying from 0.65 to 0.85. Okay, so VT equal to volume of water divided by 1 minus sigma B. Okay, so another formula that we will be using is additional volume coefficient for horizontal stream. Additional volume coefficient for horizontal stream. The formula will be VW, or this volume of water in tank. Okay, water volume in tank, VW equal to CB into S into QP into 4 into N max. Okay, so CB is the additional volume coefficient. Okay, for horizontal tank you can give S is equal to 1.25, and for vertical tank you can have 1.05. So you will be having a cylinder. You can have a vertical cylinder as well as you can have a horizontal cylinder also. Okay, you can have horizontal cylinder as well as you can have vertical cylinder also. Okay, uh, and S is the safety factor, and Nmax is the hourly starting frequency of the pump. So in 1 hour, how much time it will start? Okay, it will start and stop. How much time it will start? Okay, it will be depending. Okay, normally it will be 6 to 8 times per hour. Okay, that is the hourly starting frequency of the pump. Okay, so 6 to 8 times per hour. Okay, 6 to 8 times per hour. Okay, and yeah, S is the safety factor. That will be 1.5 to 2. Okay, S is the safety factor. Okay, now this is the just an example of booster pump only. Booster pump pressurized system, balloon type. Okay, from here it will be supplied to the individual fittings. Okay, so from the tank it will be taken through the booster pump, then the pressure tank, and from there it will be given into the individual fittings. So I will show you. This is the booster pump. Okay, pressurized system balloon type only. So normally the booster pump will be like this, and you will be having one or two pumps, and that two pumps will be attached to a pressure tank will be there. Okay, here only the water will be stored. So normally it can be 40 in our normal house residence and all, where I have used is 40 liters tank is there, 60 liters tank is there. Okay, it depends. Okay, depending upon the need. Okay. So this the water can be used for direct supply of water. Okay, direct supply of water. So and not only that, we can keep this booster pump we can keep in the ground floor directly from the over to the from the underground tank we can supply it. And in some cases, after the overhead tank also we'll be keeping this. Okay, in some cases like what happens is that I have already explained to you, like the water is being uh, drawn from the overhead tank and it will be given individually to the fittings. So in some cases, as as the pressure is very less because there is a restriction in the overhead tank height. In some cases, there will be a restriction in the overhead tank height. We cannot keep the overhead tank to a higher level. So what we do is that instead of lifting the height of the overhead tank, instead of that we'll be using this booster pumps or pressure pumps. Okay, after the overhead tank also. Okay, so that also is possible. That also we can do. Okay, so these are the pumps. There will be a pump with tank will be there. This is the steel cylindrical tank. This can be vertical type as well as it can be horizontal type. Okay, so there are different types of booster pumps are there. Okay, and let's see. Spear booster pumps is there and balloon type is also there. Okay, spear booster pumps are there and not balloon, it's domino booster pumps are there. So here, what do you mean by that is it is used for boosting the water to top floors when the hydrostatic pressure at the inlet of the flat is less than the recommended pressure required. So if the if the pressure is very less at the inlet, okay, or at any fittings end, we can use what? We can use the booster pumps. Okay, we can use the booster pumps. Location where it is been located, usually it will be in the attic or on the roof. So mainly it will be kept on the roof, okay, or on the attic. Attic means, do you know what you mean the attic? No, there is a space above our roof, not above our roof. There is in olden days and all. In olden days and all, there will be a ceiling. There will be a false ceiling like that. It will be made up of wooden thing, and above that there will be a free space. There will be a lot of free space between that. Okay, so if you have a location, an attic location like that, you can keep it there also. Okay, so it is used for boosting the water to top floors. Okay, top floors in the sense, maybe if it is a five-story building, when there is an overhead tank, okay, in the case of an overhead tank, the pressure will be very less in the top floor only. The pressure will be very less in the top floor only, and below that floor, you will be having a sufficient height by the gravity. Okay, or if you are keeping this booster pump in the ground level, you need not to reach to the top level. What you need a sufficient amount of pressure. Okay, to reach to the top floor. Okay, so to get that, we'll be using booster pumps. Okay, we can have a different capacity pumps. Okay, You can use one or two or three or like that it goes. Then as a rule of thumb, so what should be the capacity? Okay, as a thumb rule, how can we say what is the capacity of the booster pumps? Okay, normally like as a rule of thumb, you can keep it in mind, or if you want to note it down, you can note it down. As a rule of thumb, the vessel capacity, this vessel capacity or the tank capacity is about two times the actual pump discharge. Is about the two times the actual pump discharge. What do you mean by that is, if when the water from the pump is being discharged at the rate of 2 liter per second, simply 2 liter per second. Okay, so in 1 second 2 liters, that won't happen, but I'm saying, or 0.5 liter per second. Take that example, 0.5 liter per second is the discharge, if you imagine like that. So as a rule of thumb, the vessel capacity is about 2 minutes the actual pump discharge. So if it is coming, for example, it is 1 liter per second, 1 liter per second, the tank capacity will be how much? If the flow is in one liter per second, so 1 minute will be 60 seconds. Okay, 2 minutes will be 120. Okay, 2 minutes will be 120 seconds. Correct? So 120 seconds. So 120 liter will be tank capacity. 120 liter will be the tank capacity if the flow is 1 liter per second. Okay? So that's what it said. It's a thumb rule. As a rule of thumb, the vessel capacity is about 2 minutes the actual pump discharge. Okay, from the pump discharge, that the water will be staying for 2 minutes. Okay, so that is the a thumb rule. Okay. Now, domino boosters. It is used for boosting the water to top floor. Same thing. Okay, different types of it. When the hydrostatic pressure at the inlet of the flood is less than the recommended pressure requirement. It is also kept in the attic or on the roof. Okay. So now we are dealing with auto pneumatic system only. So we can do some questions. Okay, we can do some questions to make as a thorough thing. Okay. Uh, Normally, this pump, we purchase from outwards, and depending upon the type HP and depending upon the uh, tank capacity. Depending upon the tank capacity, you can measure. Okay. So when we know the flow rate, when we know the flow rate of different fixtures, how much liter of water can be will be used by a particular fittings. Okay. With respect to that, we can get the booster pump capacities are there, the tank capacities are there. But here, what we are doing is that by the help of formulas that we have seen, we are going to see different answers. Okay. So here it is being asked that design the capacity of the auto pneumatic system. Okay, for firefighting arrangement, okay, hosiery, for a high-rise building, a firefighting pump which discharges 2.5 liter per second. So, we have to find out the capacity of the auto pneumatic system for a firefighting arrangement, and it's a hosiery only for that's a pipe which are having a reel. Okay, for a high-rise building, a firefighting pump which discharges 2.5 liter per second. The firefighting pump has a discharge of 2.5 liter per second. Okay, 2.5 liter per second is the pump discharge, and we need to know the auto pneumatic capacity of the tank or the capacity of the auto pneumatic system. Okay, and the pump discharge is 2.5 liter per second. Okay, 2.5 liter per second is the pump discharge. Okay, so we are going to find out what should be its tank capacity, cylindrical tank capacity. Okay, so let's see. So this is the hydro-pneumatic. This is the hydro-pneumatic system. Okay, we'll be having one or two or three pumps. Okay, and here one connection will be attached to the cylinder. There will be a cylinder also, where the water as well as store. Okay. So this is the formula. Okay, this is the formula only that we have seen only VT equal to VW divided by 1 minus sigma A. Then VW is equal to CV into S into QP into 4 into N max. That we have seen it. Okay. So this is the question. Design the capacity of the auto pneumatic system for a firefighting arrangement for a high-rise building. Okay, a firefighting pump is discharged 2.5 liter per second. So the discharge Q value for the pump is 2.5 liter per second. We are going to find the tank capacity. Okay, so you know the formula dW is equal to CV into S into QP into 4 into N max. Okay, so all these values are given values only. You can see here. Is the additional volume coefficient. Okay, horizontal tank, if you are dealing with horizontal tank, it is 1.25. Okay, it is 1.25. The CV will be changing. Okay, the CV means additional volume coefficient. If you are using horizontal tank, the CV will be 1.25. If you are using vertical tank, the CV will be 1.05. Okay, yes, it's the safety factor. You can give 1.5 or 2. And the QP is the flow rate. Okay, QP is the flow rate, and N max is the hourly starting frequency of pump. It will be 6 to 8 times per hour. Okay, so let's see. This is, we can take 1.25 and CV 1.25 and yes as 1.5. Let's see how much is taken here. So yeah, this is the formula. EW is equal to CV into S into QP into 4 into N max. Correct. So CV I have taken as 1.05. So for vertical, so I have chosen here as a vertical tank. So for vertical tank, CV, that coefficient is 1.05. Yes, yes is the safety factor. It can be from 1.5 to 2. You can take 1.5 as the safety factor. Now QP, QP is the discharge. Okay, QP is the discharge. It is given in liter per second only. So we have to convert it. Okay, you have to convert it. This liter you have to convert it into this liter you have to convert it into meter cube. So 1 liter is equal to or 1000 or 1 meter cube is equal to 1000 liters. 1 meter cube is equal to 1000 liters. So we have to divide by 1000 in order to convert to meter cube. You have to divide by 1000. The seconds is being converted to hours. Okay, so this is converted to hours. So liter per second only, that has to be converted to hours. So you have to multiply with 60 into 60. Okay, you have to multiply with 60 into 60. So CV equal to 1.05, S is equal to 1.5, QP is equal to 2.5. Okay, liter only, that has to be converted to meter cube. So divide by 1000, and this seconds has to be converted to hours. So you have to multiply with, here you have to multiply with 60 into 60. Okay, and this 4 into N max. N max, how much it was? Hourly, hourly starting frequency of the pump is 6 to 8 times per hour. So you can take maximum. Okay, 8 times per hour. You can take 6 also. Okay, so this is 8 times per hour. Okay, so that only we have to make all the units same. That's why this liter per second has been converted to meter cube by hour. Okay, so 1.5 into 1.05 into 1.5 into 2.5 into 60 into 60. Then we will be changing it to hour. Divided by 4 into N max. N max means 8. Okay, this 1000 means this liter is being converted to meter. So when you are multiplying all those things, I think you may get 0.443. Here you can just change. Okay, you can bring this 8 as 6 or 7 or 8. Okay, so according to that, this will change. So you got VW. Okay, you got VW, water volume in tank as the volume of the water in the tank as 0.5 443 meter cube, volume of the water in tank. So VT, volume of the tank, you know the formula. What is the formula of VT? VT is equal to VW divided by 1 minus sigma B. Okay, VW divided by 1 minus sigma B. So 0.433 divided by 1 minus sigma B. Sigma B is a constant, right? It will be in the ratio of 0.65 to 0.85, right? So you can see here, sigma B, where is sigma B? Sigma B, you can see here. Ratio of minimum and maximum working pressure varies from 0.65 to 0.85. Okay, 0.65 to 0.85. So 0.65 to 0.85, then what will be the value? 0.65 to 0.85. You can take 0.65. Okay. So 0.443. So this is not 433. Okay, this is 443 only. Okay. Just try to find whether you are getting this 443 or 433. Just multiply and see whether you are getting this answer or not. Whether you are getting answer 443 or 433. Are you there? So anyways, we can take this 433, okay, 433 or 443. Just try and see. Then VT is equal to VW divided by 1 minus sigma B. Sigma B is 0.65. When you get in it, you will be getting total volume of tank is 1.26 meter cube. So total capacity of vertical type steel pressure tank is 1.25 meter cube. So you can take one round it and you can write 1.25 meter cube. So we got the tank capacity as 1.25 meter cube. Okay, we got the tank capacity as 1.25 meter cube. Okay, so next, in order to know the height and the, if you are taking the round type, you know, steel tank, what you have to do is that you can assume the diameter as 1. Okay, according to that, this length will change. Here I have taken 1 meter as the diameter. So according to that, this 1.6 is the height. Then you are taking in the formula. If you are trying to give 0.5 meter, according to that, the length will increase. Okay, so you can assume a cylindrical, diameter for the cylinder, or you can find out or you can assume the diameter of the cylinder. According to that, there will be change in the height. So, for example, the total capacity of vertical steel pressure cylinder is 1.25 that we have found from here. Assuming the diameter of this tank is 1 meter, Q you already know it is 1.25, diameter is 1 meter, you have assumed it. You have to find the length. Okay, so you know that the area is equal to pi d square L by 4 for a cylinder. That is the volume. Okay, the volume will be pi d square L by 4 is the volume. So we know the volume. So volume is equal to pi d square L by 4. So d square you already know it is 1. So from there you can find the L. So L you will be getting as 1.59 meter. So the length of the cylinder will be 1.59 or 1.6, and diameter of the cylinder will be 1. Okay, so that is one of the question. Now, second question. Design the capacity of the auto pneumatic system. Design the capacity of the auto pneumatic system if the discharge of pump is 0.96 liter per second. So the discharge of pump is given 0.96 liter per second. Here in this question the discharge of pump was 2.5 liter per second. Here the discharge of pump is 0.96 liter per second. And one more thing is given, the discharge through one fire hose reel is 0.4 liter per second. So the discharge from the pump is 0.96 liter per second and it is being discharged through two different hoses. Okay. One fire hose discharge is 0.4 liter per second. So you can see how much liter per second will be passing. Okay. So you can see here the simultaneous discharge for two hoses. 2 into 0.4. So it is said that discharge through one fire hose reel is 0.4. So and the total pump discharge is 0.96. So we know that it will be almost 2 times, correct? So the 2 times of 0.4 is 0.82, 0.8 liter per second. So the discharge of the pump is 1.2 times because you know through one hose it is 0.4 and through the other hose also it is 0.4. Okay, so total will be 0.8. And the actual discharge from the pump is 0.96 liter per second, which means that the discharge of the pump is 1.2 times of this water which is flowing through one hose. Water will be flowing through the both the hose. Okay, the water which is flowing through the both the hose, the actual pump discharge will be 1.2 times. It means 1.2 into 0.8 will be 0.96. Okay. Okay. Now, so the required discharge is 1.2 into 0.8 is equal to 0.96 liter per second. Okay. So this is just for our general idea only. Now we can come to our solution. Capacity of steel tank, we know volume of tank is equal to VW divided by 1 minus sigma B. VW, we have already know the formula CV into S into QP divided by 4 N max. So here CV we can take as vertical, so 1.05. Yes, safety factor 1.5. QP is equal to how much? 0.96 liter per second. That has to be converted into meter cube by hour. So 60 into 60 divided by 1000 and divided by 4 into N max. N max you can take as 6 to 8 only. You can take maximum 8. Okay. So from there you will be getting VW to 0.170 meter cube. Now we got VW. Now we take this in this formula. VT equal to VW divided by 1 minus sigma B. So VT equal to VW how much? 0.17. 0.17 divided by 1 minus sigma B. Sigma B we already know it's a constant. It is 0.65 to 0.85. So you can take 0.65. And you got volume of the tank as for 0.486 meter cube. So you can round it and we can write as approximately 500 liters. 500 liters is the tank capacity. The same way, we can find out the dimension of the tank. So you can assume here 0.5 as the diameter, 0.6 as the diameter. And the volume is equal to 0.5, approximately 0.5 meter cube. Pi by 4 d square into L is the volume of the tank. So here instead of 1, in this question we have taken 1 as the diameter, assumed as 1. Here we have assumed as 0.6 only. So we have 0.6 the whole square into L divided by 4. From there you will be getting the length 1.76 is equal to 1.8. So the assumption of this diameter you can do it. Okay, you can give it as 0.5 or 0.6 or 0.8 or 1 according to your need. So what is the diameter that you are getting, according to that this length will change. Okay. So let's see for the final question. So we can make it thorough. Okay, we can make it thorough. So if the capacity of the, now it is given us, if the capacity of the pressure cylinder is already given. If the capacity of the pressure cylinder is 1.25 meter cube and water is 0.44 meter cube. So you know that the total capacity of the pressure cylinder is given, and the inside that cylinder there is water as well as there is air, and the water is also given. The capacity of the water inside the pressure cylinder is given as 0.44 meter cube. Okay. Now, if the air in the tank reduces to 0.115 meter cube while pumping, okay. So while pumping, what happens is that the air in the tank reduce. Okay, you know that inside the tank there is air as well as there is water. So the when pumping occurs, what happens is that the air in the tank reduced to 0.115 meter cube, and they are asking what height water can be pumped. So how much height? What is the head of the pump? Or how much height the water can be pumped? The cylinder capacity is 1.25. Water inside the cylinder is 0.44 meter cube, and then it is pumping. If the air is reduced to 0.115 meter cube, so at what height the water can be pumped? That is the question. So let's see. The capacity of the steel tank, you know, it is 1.25. Volume of the water in the tank is 0.44. So if this box is given, you can easily find out the volume of the air, right? Because volume of the tank is equal to volume of the water plus volume of the air. So volume of the air is equal to volume of the water minus volume of the air is equal to volume of the tank minus volume of water. So volume of tank, you know, 1.25. Volume of cylinder is 1.25. Volume of water is 0.44. So the volume of air in the tank under atmospheric pressure is 1.25 minus 0.44. It is 0.81 meter cube. So volume of the air of tank is 0.81 meter. Volume of tank is 1.25. Volume of water is 0.44. Okay. So volume of water is 0.44. Volume of tank is 1.25. Volume of air is 0.81 meter cube. Okay. So we know the atmospheric pressure is 1.1.33 kilopascal. That is a normal atmospheric pressure. Okay. So volume of air after pumping, what happens? It says that it reduces to 0.115 meter cube. So actual volume of the air in the tank is 0.81. After pumping, what happens is that the tank pressure reduces to or the air in the tank reduces to 0.115 meter cube from 0.81. So according to Boyle's law we already know, we are studying from class itself. P1 V1, okay, pressure 1 into volume 1 is equal to pressure 2 into volume 2. P1 V1 is equal to P2 into V2. So P1 is the atmospheric pressure, P1 is the volume of the air, okay, total volume of the air equal to P2. P2 into 0.115. So we are going to find what is the height if the air in the tank reduces to 0.115. So if they are doing this formula, P1 V1 equal to P2 V2, we can find the P2. And we can find the pressure. Okay. So if we know the pressure, we can easily find out the head. Okay. So P2 is equal to, we can just bring it here, and when you are dividing with this, you'll be getting at almost 730 kilopascal. 713.71 kilopascal is the pressure. Okay. P2. So you know the gauge pressure. The gauge pressure will be absolute pressure minus atmospheric pressure. So this is the absolute pressure that we got. Okay, inside the tank, the absolute pressure. So absolute pressure minus atmospheric pressure, it's a constant, you know, it is 1.1.33. So absolute pressure minus atmospheric pressure is the gauge pressure. So 713.71 minus 101.33 is equal to 612.38 kilopascal. That is the gauge pressure. So if you are dividing the gauge pressure with 9.81, okay, you'll be getting its head. You'll be getting its head. So divide by 9.81, will be the kilopascal can be converted into meter. Okay. So by the gravity, you know, when you are trying to divide, you know, you'll be getting its height. Okay. So 62.42. When 612.38 divided by 9.81, you'll be getting 62.42 meter. So the theoretical, so when we calculated by the formula, we got 62.42 as the head, which means that the theoretical height up to which water rises, or the water can be pumped up to 62.42 meter. But in the actual case, in the actual practical case, theoretically we can say that it is 62.42, okay, meter, which means that 62.42 meter can be pumped. Right? At that height, it can be pumped, or water can be reached there. But in the practical sense, you know that many fittings will be coming inside between the pipe, correct? So that there will be friction loss. Okay. So while reducing that, you know, it won't be actually 62.42. So the actual height will be less than that. That is, actual height will be theoretical height minus the friction loss in pipes and fittings. So we have to reduce the friction loss in the pipes and fittings. When you reduce that height, you will be getting the actual height. So at what height means, you know, you have to find the friction loss and you have to reduce it, and you can find out the actual height with which the water can be pumped. So theoretically, you can say 62.42 meter height, you can pump it. Okay, so this is the auto pneumatic system. Uh, so we have studied how to find the capacity of the pressure tank. Okay, and we have studied if the pressure tank capacity and the water capacity as well as the air capacity is given, and at how much height we can supply the water. Also, we have studied. And we have studied about the auto pneumatic system. And one more thing, jockey pump is mainly called as jockey pump. Okay, this jockey pump important is very important in the firefighting system. Because in the firefighting system, there are two pumps. One is main pump and another one is jockey pump. When a fire occurs, this main pump will work. This main pump will work, okay? And it will be giving the water to the space where there is fire. Now, we have another one thing which is called as jockey pump. So you know that in firefighting, the pipeline should be always pressurized. If there is fire or if there is no fire also, the sprinkler and all those, pipelines, it should be in a pressurized state. So what happens is that this is an ideal state, right? Because we are not using it. So in this ideal state, what happens is that sometimes there may have a leak. Sometimes there can have some leaks in between the pipelines. So what happens when there is a leak? The pressure inside the pipe will be the pressure inside the pipe will be reduced. Okay? So in order to maintain the pressure inside that pipe, we will be using jockey pump. Okay? If there is a reduction in the pressure inside the piping pump, this is jockey pump is a small pump. Okay, the jockey pump will help us to maintain that pressure. Okay, help us to maintain that pressure. Okay, so always the pipeline will be in a positive, will be in a high pressure state. So it will make sure that if there is some leakage, then also what happens, the jockey pump will actuate. Okay, when it comes to a set point, when it goes reduce, when it is goes below say set pressure, the jockey pump will stop and it will give a proper pressure to that pipeline. Not only that, if there is no pressure inside the pipe, if this main pipe for the firefighting system is a high capacity pump. So if there is no pressure, okay, what happens is that once the fire occurs, when the water or when the pump is being on, high pressure, water will be flowing through the pipe. High pressure water will be flowing through the pipe, and what happens? It will break all the sprinklers and all those things. Break completely because of the high pressure. In order to save that also, this booster pump can be used. So just I will explain or just I will dictate what is that. It is developed jockey pump. It is designed to keep the pressure in the system elevated to a specific level, and the system is not in use so that the fire pump doesn't have to run all the time, and the system doesn't go off randomly. Since pipe leaks over time, the water pressure inside them automatically goes down. The jockey pump senses this and then fills them back to the normal pressure. Secondly, this pump prevents sprinkler system from being damaged. Okay, so that is the use of jockey pumps. This jockey pumps will be uh, uh, very less capacity pumps only compared with the main. And this will be set it with the main pump itself. Okay, to maintain the pressure inside the tank. Okay, to maintain the pressure inside the tank. So today we have studied about the auto pneumatic system. So is there any doubt regarding the auto pneumatic system? Is there any doubt regarding the auto pneumatic system? You can ask. Is there any doubt regarding the auto pneumatic system? No. Okay. So one more thing, I have already said you that I will show you my project. Just I will show you the project that I have did. I am not explaining all those things. Just I will show you the. Uh, let's see. That I will show you the PPT, not PPT. Let me see. Okay. I will show just I will show the pump layout, or I will show you the. One second, please. I will show you the schematic layouts. So as I will show you the pump room layout. Yeah, this uh, one project I will be showing you in the last class. In the project, there will be a project implementation class. There will be a project implementation class. So in that project implementation class, I will be taking a live project. Okay, and I will show you how to how we are taking the pipe designing, overhead tank, underground tank, all those things I will be teaching you in the last class. Okay, there is a special project implementation class for you. Okay. So I will share my screen. Just, so one second. So this is just the schematic diagram only. Okay, just the schematic diagram. This is the pump room layout only. Okay, this is the pump room layout. This is only a pump room layout where you can see this is the raw water tank. This is the uh, air room only in between these two, and there is a fire tank also. This is a fire tank. Okay, this is a fire tank. Okay. You can see the capacity is 2 So from there, you know, this is the auto pneumatic system. This is the pump. So this is the pump. This is the auto pneumatic system, and this is the tank. Okay, this is the pressurized tank that I have shown you. So the pressure geysers and the pressure sensors. Then from there, it is into the area. Area. It's basically a static. And the water is being given from. You can see here tank. Right now, what is this? In the last class, I will be doing a project implementation. Thank you, Sven. I think there is no doubt. Can see you tomorrow. Okay? With a new topic. And I would say the quality communication class will be taken in the hallway. Okay? In the hallway, so thank you so much.